In yesterday's lecture, I have explained mainly different types of categorical variable and the different properties, natures of data, and especially the categorical data, and if required, how we can convert categorical data into numerical data. And in today's lecture, we will see different and also some form of graphical representation of the data like pie chart and bar chart. I will use them in today's lecture also. Along with this, in today's lecture, I will mainly cover the association, the goodness of fit test, and the chi-square test. How we can use them for analyzing categorical data or to understand the categorical data. Okay, and to understand this, we will frequently use two terms like significance level and the p-value. So we will also study this, or we will also evaluate these two values, and we will see what are the meaning of the significant level and chi-square p-value in terms of categorical variable, evaluating it and analyzing it. So let's start it with some example first. Okay. So when we are talking about association, like in case of the example which I have given you in the last class, that is the market basket analysis, and finding out the association between the liquid product and the solid product. That means whether they have any kind of relationship between these two or not. Okay, and how we will find the relationship based on the value present in the two attribute, that is the category, that is the liquid attribute and the solid attribute. Okay, so now why we need to understand this association? Because in some cases, if we have the relations, if we know that two attributes are related, then we can take many decisions, important decisions, and also we can predict. We can also predict many important information from the data set. Like for example, if we can predict from the yesterday's example of market basket analysis that milk is associated with bread, or milk is associated with sugar, then there are different decisions we can take in the supermarket, that where to place milk product and where to place the bread product, and or where to place the sugar product, different sugar products. Based on this placement, the advertisement of the new product and the use of the popularity of the old product can be used significantly. Okay, so and also we can we can predict that, for example, in case of bioinformatics data set, if we can understand that one protein is associated with another protein, say one viral protein is associated with another human protein, then we can propose many drugs or the medicine which can help to cure the disease where these two kind of associations are present. And if we can protect these association or prevent those associations, then we can cure, we can give a cure, we can give a solution to cure from that disease. Okay, so there are many other applications are available where we can use associations. And to measure this association, we will mainly use in today's class is contingency testing, which is also called cross tabulation. And one widely used other methods are called like chi-square test for independence. That we will also see that how chi-square test is used for finding out the association between two attributes. And also few other, maybe you have used or you will use in this workshop, that logistic regression. And another important topic which you or measure which can be used for measuring the association by using the association rule. And there are many other algorithms. One such algorithm is a priori algorithm. And if you are interested in this domain of association, you can look at these association rules and different algorithms in this field, which where some of these algorithms can be used for categorical data. Some of these algorithms can be used for numerical data. Okay. And also, these methods are also based on like what kind of data you are using, whether it is categorical or numerical. Based on that, we choose different methods for association. So let's go ahead with the contingency table first. What is contingency table? It is nothing but a representation of frequency distribution. What is the frequency here? Frequency is the count. How many times a particular value is appeared in that particular data set or in that particular attribute. That is the frequency of that particular value in that particular data set. So the contingency table used to display the frequency distribution. That means how they are how the all the values of the considered attribute are distributed, and those considered attribute must be categorical. And minimum 2 attributes are required to find out the contingency table. We can use more values or more attributes. We will use mainly 2 attributes to explain this, but I will show you how you can use more than 2 attributes to find out the contingency table. But we will not analyze them because they will be more difficult to analyze and understand at the very beginning. So we will consider the very simple example of creating contingency table by using the 2 categorical attribute. Okay. So by examining the cell count and the percentage within the table, you can identify pattern and association between the variable. Imagine you are studying the relationship between gender and voting preference. Like in the last class, I have given you a data set of gender and voting preference. Okay, so in that case, how you can use this association to find out whether this gender and voting preference is there any relationship present between these 2 values or 2 variables or not, or 2 attributes or not. So let's go ahead with the experiment now, or the coding part. So what we will do first is the voting preference data. Let me check. I forgot where I have anything or not. Okay. So let's create a voting preference data. So everybody, I will request everybody divide your screen into 2 parts. Place my window in one part and your collab file in another part, and try to continue with me as I progress. You also practice them with you. Now, so my first example. So example of association. So first we will consider 2 variables or 2 attributes, that is gender and voting preference. So how to create the data? So for this, I will use Panda as PD, and there let me check. So let's create some data set. Okay, in today's lecture, I will mainly continue for 1 hour with this association and other 2 concepts. And after 1 hour, I will mainly go for an example of economic data set as you have requested. So I will use that data set and I'll try to analyze those data and try to discover many information from the data set. Okay, so let's consider this voting preference data set for the moment. And instead of, I have one temporary data set for this. which I can find out. Okay, just a minute. Okay, now what you have to do, you have to create a data frame df equals pd dot data frame data, and the data will be as you have already seen, so I am not going into this. So this is the data. So if and the size of the data is very small. Okay, so I will show you now. Before going into the association, let's create a larger data which will help you to analyze it in a better way. Okay, so since we are talking about categorical data, we will consider these two categories of gender and voting preference, and we will create another large data set. So for this, what we can do, we can use some random value to create the data set of, for example, 200 rows, because if I ask you to create a 200 rows data set manually, it will be difficult. So create a data set randomly, and for that I will use the random function. Okay, and so now we will use the gender category, which is male, female, and say non-binary. Okay, so three category, and I want to generate the number of rows. Say for example, 200, and then use the gender values is equal random dot choices, random choices from where? Random choices from the categories, that is gender category, and how many? That is k is equal number of row. So that many gender values will be created, and next I will create another one, that is gender, and another one is voting pref. Okay, so voting pref will, where you have what are the categories candidates you have. How many candidates? Say candidate A, candidate B, candidate C, and then the undecided. Okay, undecided. So these are the category, like gender category, and the number of rows is already defined. Okay, number of rows is already defined. So I have to generate gender voting values. Voting values is equals. You can use the same function, or you can use, there are many other random functions are available. You can use them. So random dot choices, and then voting pref, comma k equals number of row. And after creating these two value, what I can do, I can create a data. I can create a data. So let's run this, okay? And let's run this and check whether there is any error. So it's run properly, and if you check it, the value, and there are 200 items, female, non-binary, male, and then in the case candidate C undecided, like this, there are 200 values. Now create the data by using the same dictionary function or dictionary variable representation. So here what I will use, that is the name of the column will be gender, where the values will be gender values, comma. The next attribute is voting preference, or the preference in short, preferences. Okay, preference, and the values are voting values. Okay, so with this, if I run this, before that, let's convert it into data frame pd dot data frame, and that is data. The same way I have used earlier also, print df. And now you see a data set having 200 rows have been created in a fraction of minute. Okay, now we will try to, either you can use, so better you can give this one as a name data frame 1, and you can give the data name data frame for this. Okay, so now we will try to find out the contingency table from this data set, both the data set. So let's find out the contingency table. Contingency table of the data set. So for this, in Panda, you have as for contingency table has another name, that is the cross tabulation. Just for your easy understanding and memorizing the fact, cross contingency table also called cross tabulation. So the function in Panda, one function is in Panda is available, that is called cross tabulation, cross tab. Okay, one function is available, cross tab, which is equivalent to the contingency table, where we will use this to generate a contingency table. We will use that function on the variable or on the category of gender and preference. Okay, so let's use these two value as the argument. So gender here, and another one is df voting preference, or only preference, right? So since it is the data frame, so we have voting preference. But in case of data frame 1, so in case of data frame 1, we have only preference. Data frame 1, data frame 1. Okay. So where we will use this or store this in a contingency table, and we will also store this in a contingency table 1. So let's look how this contingency table looks like. So for this, I have to print it. Print contingency table. contingency table 1. So let's look at this for the small data set and see here the contingency table. How to understand this table? It says that the candidate A, number of vote candidate A got is 5, number of vote candidate B got is 3, and undecided is 2. So a total out of 10, 2 is undecided, 3 is, goes for candidate B, 5 goes for candidate A. And out of 5 goes for candidate A, 2 are female and 3 are male. So male candidate prefers candidate A and female candidate prefers candidate B or undecided compared to candidate A. Because together candidate B and undecided it is 4, or you can say the choice of female candidates are almost equal for candidate A, candidate B or undecided. Okay, so and male candidate prefer not to be undecided. They took the decision for the voting. Either they choose candidate A or candidate B. They have the male candidate have not chosen any undecided places. Okay, so this is one example of this small data set. Now, if you go with a bigger one, now see in this case. So here, in case of male and female, we have 3 values: male, female, and non-binary. So if you look at this, the non-binary candidates chosen candidate B to vote, okay, in a greater way. But male candidate chosen candidate A, or candidate A got the highest vote from male candidate. Candidate C got highest vote from male candidate. So, and also for undecided, there are male candidate who kept undecided in the largest number. So, male candidate has a very significant role in case of voting, whether it is candidate A, candidate B, or candidate C, or it is undecided. So, the importance of male voter to the candidate is very important compared to the female or the non-binary candidates or non-binary voters. Okay, but in case of candidate C, it is not. Candidate C has more important. Candidate B has more importance for non-binary voters compared to candidate C and candidate A, but the male candidates, male voters have much importance. Is it understandable what I am talking about?
Sir, I had one question.
Sorry?
I had one question.
Yes.
Questions.
Hello?
Hello. I have one question, sir.
Mm-hmm.
So random is something. It's a file in Excel, something where you save those that thing. When you said import random.
This one, right?
Yeah.
Yeah. So let's
Random
go.
is a file. Yeah.
Yeah, let's go a little bit more in this random function. So if you go, if you search in Python, there are 2 ways you can generate or you can use mainly. There are many others, but there are mainly 2 ways you can use this random function. One is present in NumPy library, and another one is a Python classical library. Okay, so if you search for random number generator in Python, then see here you have Python NumPy. So if you go with this, okay, so NumPy library is here, the official website of NumPy, and there you have random generators, numpy.random, which I have not used here. I have used which one? I have used the normal random values. Normal random values. That means, so random in Python. So there you have generate pseudo random numbers. You have Python docs. So from there you can see you have random numbers, number generators. I have used this one where you have under this random you have choice function which generates some set of values, and from where I have used mainly this one. Okay, I have used mainly this one. So what it says, the return a k size list of element. K size which I have mentioned is 200 from the population with replacement. If the population is empty, there is index error. So the population means the, okay, let's go in the code. So here the population is this one. This from there, from this list I have chosen values. How many times? 200 times, and then it generates 200 random values from this set of values and creates the gender value.
Okay, sir. Randomly, it did it on its own, randomly.
Yes,
Right?
randomly. But although in the back end, randomness is also statistically there is nothing random. Everything has some calculation in back end. So, but basically we choose it randomly.
Sir,
Okay.
I thought that you have already created an Excel list where you have put in data for 200 voters and included their male, female, and then their references. Like if we do it manually, suppose I've got 200 data points of 200 individuals. Okay, 1 to 200, and for each candidate, I'm putting in their male gender, like male, female, non-binary, or female binary, and that, and then their subsequent preferences for candidates A, B, and C. So we can go via that also now. Like this is so you have created randomly. Suppose I have a data set on my own.
Yeah, I got it. So let's say, for example, we have sample data set, right? Any data set. So, for example, that can be in an Excel format like this, or can be in a CSV format like this. Okay, so you can have it, but since it will take another couple of minutes to explain this, maybe you have already came to know about the process of loading the data from the data set. If you have not, it is not explained yet. So just a brief overview of that. That if you have this kind of data set, okay, say diabetes data set, course evaluation data set, or any such like company stock data set. Okay, I have used some data set like iris data set, or in Python there is a data set in Python, pandas. In pandas you have some data set available for your experiment, okay, for your use. You can use them also. So no, exactly, I can't remember exactly. Let me search. Give me some minute. Or you can, if you go to the Python library, Panda library, you can see there are many data set are available for your use. It is Panda or data frame sampling NumPy. Yeah. So this one. So here there are many data sets are already available for your use. You can use them directly. Okay, you can search in Python. There are many such data sets are available. See, and from that data set you can also create random data set for your own purpose. Okay, so and if you this is one side. Another side is if you have this kind of data set, then what you can do in Python, there is a way to load the data set, the Excel file, CSV file, or something like this, or text file. You can read them and convert the data frame. Once you create the data frame, after the remaining process is okay.
Show how to load the data.
Shall I show you?
Is in CSV format or Excel format, whichever format.
Okay. So the easiest way to go first, maybe this Irish data set. Okay, you can have many such data or company stock. How long it is? Let's take a small one. Maybe this one is not a good one. Irish is a good one. It's a small one. Okay, so let's download it. Say consider this file is present in your in your computer. Okay, so now I say I want to load it here. Loading data set. So the easiest way, but the not the good way, is to load it in the collab environment. Collab environment means here in the right hand side, in the left hand side, if you look at this portion, there you have a folder sign. Okay, click on this folder symbol. Okay, and then you see there are some sample data set are available, like California housing test, California housing train, mean test, mean train. So for classification problem, you can use them directly for a small experiment. But if you want to use that which you have downloaded there in your computer, or you already have some file, so you click this button, that is this one here. Okay, and choose the file which you have downloaded, this one. So see what error is, as I said, this is the easiest way but not the good way. So it says that ensure your file are saved elsewhere. This runtime file will be deleted when the runtime is terminated. So every time you want to run it, you have to load it in the environment. Okay. Else there are many other ways to do that. Like you can load the file, or you can use a file which is available in GitHub. You can load a file. Let's go one by one if you don't mind before going into the other part. So here, so let's df1 is equal pd dot read, because it is CSV file, so read CSV, and which file I want to use, iris dot CSV. Okay, so data frame 1 is okay. I have data frame 2 should be. So print df2. It is as easy and as simple as that. Okay, you have 150 rows, and these are the values, numerical values. So this is the simplest way to load a data set and use the data set. If you have any data set, you can use it for your own purpose by this simple way. Or say you have one GitHub, data set. Shall I go with this, or this simple one is okay for the moment? Anyone is interested to look at the loading process from GitHub, or I will skip it?
Sir, show once GitHub also, and then we can go for the other topics.
Okay. So for the GitHub, let's find out a data set, the same data set, okay? Iris GitHub data set. Because most of the nowadays people upload their data set in GitHub, and instead of downloading and then uploading and use it, which you can do, you can directly use the GitHub data set. Say here you have the data set, okay? Or you go there and it is the code. I need a good file, a good repository, where I can explain few more things. So this is the data set. Okay, where you can find it? In JB only, a machine learning mastery account, okay, GitHub account. There you have a data set repository. You click this and you see that here you have many CSV files. Okay, I want to use the same Iris data set present here, that Iris CSV. So when you click on that particular data file, you got a link, this URL. But this URL is not a good one to use. This URL present here is not the one you have to use it. Which one you have to use? You have to click this raw. You have to click this raw button, which you can find out in the right hand side of the GitHub screen. And then the link you get is different than the previous one. And then you copy this link. You directly copy this link and come to the collab file where you are where you plan to use this Iris file. So now you create a you create a URL variable where you want to store the URL, and then you want to use it, right? So similarly, df3 read underscore CSV, but read underscore CSV is part of PD. We have to use that and use the URL you have copied. Okay, so now you print it df3. The dataset is already loaded here with the df3. Okay, clear? Any doubt or any queries you want to ask?
So this Iris set file and the other one which you took it from your Gmail account, these are the same or these are different Iris files?
No, they are same. Okay, but I understand your question. That is this one, right?
Yeah, I mean the sources are different from where you extracted the data, but they are the content is same. The content is same, I guess, right? The Iris file.
Yeah, the content is same. The same means maybe different. Maybe you can use the other file. Like for example, just go randomly any other data set. Say anyone. Say this one, monthly car sales. Okay, it's a binary and is a numerical data set. You copy this link. Okay, and you paste it here. Okay, and then you run it. See the data set loaded. Okay.
Okay, sir. Thank you so much.
So this is the way 1, and this is the way 2. There are many other. There are 4 or 5 different ways are available to load the data set. I have just shown you 2. You can explore later on. Okay. So now where I was previously, before going to this data loading, this part, contingency table, right? So if you look at this contingency table, I have explained these things, and you asked there that whether you have to create your own file every time, or you can load your existing file, and that's the answer I have explained. That after having the data frame, you can directly use the cross-tab function of the PD library, Panda library, and you can generate the contingency table. Is it clear? Now, going for this contingency table, little bit, let's go here. So this table for this case, in this case, I have created this one. Okay. Now you can have this table, and you can create another table that is called relative frequency table. The relative frequency table calculate the percentage of each cell. Okay, percentage of each cell in the contingency table compared to the other cell in the column or in the row. That means calculate the percentage of a cell value against the row or against the column. If you create this percentage against the row, that is called row-wise frequency table or contingency table. And if you do the same for column, it is called column-wise contingency table. So how you can do that? How you can find out the row-wise or column-wise contingency table? So let's go with these 2 examples. So code, and then the contingency table, dot div table sum based on axis 1. This is very important. This value axis is equal 1, and then axis is equal 0. So this will generate one way of one table that is called row relative frequency table, and then for the column frequency table, you create 1, you create 0. Okay, so print row relative frequency table and print call relative frequency table. See here, if you do the sum of this is the row frequency table, right? Relative frequency table. So if you do the summation of this is the 100%, and if you do the sum of this is the 100%. Okay, and similarly, in case of column, if you do the sum of these two value, okay, 4, 5. So the 0.4 and 0.6, this is 1% or 100%. And if you make a percentage and use do the sum, you will get 100% here and you will get 100% here. So as the way you get the 100%, it is called that way of relative frequency table. You get 100% as per column, so it is called column wise relative frequency table. If you get the 100% based on the rows, then it calls the row wise relative frequency table. And instead of number, you can get better answer, better explanation of the same question, so same answer, so not the question but same answer which you have generated from these two tables. What are those answers? That 75% of the male candidate, 75% male candidate prefers candidate A, and 25% male candidate prefers candidate B. Okay. Similarly, here 100% female candidate, or those who have voted for undecided, 100% of them are female. So instead of number, here you can say this in percentage by using the relative frequency table. If you have any query, you can ask me, or else I will go to the next concept, that is the chi-square test for independence. And as I said, there are many other tests. You can try them, you can explore them at home. So what are the assumptions here in case of contingency table? That it should be independent, random sampling, expected cell frequency. We will see very soon later on all of this. Now, let's go with a, okay, we will come this example after a few minutes, okay, with this interpretation and then let's go with the goodness of fit test. Goodness of fit test is nothing but another statistical test which determines whether data comes from a specific population or follow a particular expected pattern. Okay, tests are commonly used to validate assumptions about the data and make inference about the population. That means, when we are talking about sample mean and population mean, that means sample is a part of or a set of population. Population is the largest one, where you have all the samples or all the data, and from all the data from the population, you choose some set of data, and those some set of data are called sample. So from the sample, because the sample size is small, from the sample we try to find out some, or try to take some decision, or try to find out some hypothesis, or some assumptions can be true or false, and then we apply on that in population whether that will fit for the population or not. Okay, so that will tell you the goodness of fit test will tell you that for a particular sample data, if you have some assumption, whether that assumption is valid for the population or not, and this choice of appropriate goodness of fit test depends on the type of data and the distribution or model you are testing against. That means to get the value of goodness of fit test, you have different models are available. Each of those models, some of those models can apply for categorical data, some of those apply for numerical data. So what is the idea behind this goodness of fit test? Compare the observed data with the expected data that would result from the hypothesized probability distribution model. Test produces statistics that quantify the degree of agreement or disagreement whether that hypothesis is true or false. If the observed data significantly deviates from its expected value, under the assumed model, it may suggest that the model is poor fit for the data. Okay, so that means that assumption will not fit for the population. So there is a two way to do that. That chi-square goodness of fit test, which we will see, and there are many other like Kolmogorov, Smirnov test, Anderson-Darling test, goodness of fit test for Poisson, normal, and exponential distribution. As I said, that there are many in the previous slide, that many distribution models you can use. So based on that, the goodness of fit test actually value generates. For example, how goodness of fit test can give you some understanding. Say, for example, imagine a chocolate chip cookies. That means a cookie where you have different where you have chocolate chips. Okay, small chocolates in that cookie, and then you want to in your company, say you have a company of chocolate chips cookie manufacturing company, and you want to advertise that in your cookies you have 20 more or less 20 chocolate chips for each of the cookies. Okay, so whether the advertisement, the value is true or false. Okay, say for example, it is not your company, someone else's company, and you are eating the biscuit and you want to test that hypothesis, that whether how many chocolates are there in a particular cookies. Okay, that to understand that whether the cookie is good for that price or not. So company, you want to test if there is their claim is accurate. So to do this, you bought 100 cookies. Okay, randomly chosen 100 cookies from different packets, and then you count the number of chocolate chips present in those cookies. So that is the sample size, because company are producing millions and billions of cookies every day or every month. So having all those samples or all those biscuits or cookies to test is not cup of tea. So what you can do, you randomly choose 100 cookies from different packets and then collect the number of chocolates in those chips. Okay, and chocolate chips present in those cookies. After collecting the data, they perform a goodness of fit test using the chi-square test to compare the observed distribution of chocolate chips in the cookies to test the expected distribution based on their claim. So for this, you have to test the hypothesis first. You have to assume, you have to create a hypothesis that the observed distribution of chocolate chips in the cookies matches the claim distribution. That is, on average of 20 chips per cookies are present. That is true. That is a null hypothesis. And the alternate hypothesis, if this is not true, that means the observed distribution significantly deviates from the claimed distribution. That means there is either less or more than 20 chips per cookies. Okay. So you create the data set of 100 cookies and then create the table of expected and observed frequencies. So how we can do that? Say, goodness of fit test, and here say the observed data is equal to np dot array, say the values are 18, 21, 22, 16, and 23. You can randomly generate this data set. I have just taken 5. Instead of 100 data set, 100 cookies, I have taken 5 cookies and counted the number of chocolate chips present on those cookies. Okay, so import numpy as np. Now create the data set. Data set is created. Observed data set is created for 5 population, 5 sample size. Now for the 20, create the expect distribution model. Okay, expected distribution model. So expected dist is equal np dot array, and there you have, so this 20 multiplied by length of the observed data. Okay, and say so this is the observed data, and here expected distribution, say 20 20 20. How many? Because you this is your expectation. Okay, because in all these cases you have 20 20 20 20 20, but in some cases you have 16, some cases you have 23. Now, how to find the goodness of fit, how to use the goodness of fit test. So for this, what you have to do, you have to use the use a function that is called chi-square. Okay, by using chi-square statistics, you will find it. So for this, we will use from SCI pi import the stats library. Okay, and then there you have a function called chi-square. Not so, yeah, chi is chi-square. Okay, and what you have to provide here is the, if you look at this, see observed frequency and the expected frequency. Okay, f expect, exp, and f obs. So you provide the observed data f exp will be the expected dist. Okay, and this will return different values. What are those values? Let's look at this. What are those values it will return? Calculate a one-way chi-square test. Okay. Maybe because of the internet or my mouse, I don't know. Okay, you can look at that. It returns many values, and one or two such values are chi-square statistic value, chi-square test value, and the p-value. You know the p-value I mentioned earlier. So the chi-square, chi-value, and the p-value. Okay, so it generates two values. So it generates two values. Now there is a significance test, as I said, significant level, which we will assume here in this case that we will assume in this case that alpha is equals, what is the meaning of this I will explain after this example, which will be easier for you to understand it. So alpha is equal to 0.5. That means 5% fault can be tolerable, or 5% wrong answer can be tolerable in this case. So if write a if condition that p val is less than alpha value, okay, if less than alpha value, then print reject the null hypothesis. Reject the null hypothesis. And else, am I audible? Hello?
Yes, sir.
Okay. Else, I don't know whether network gone or not. So, okay. Keep asking questions. Print. So, fail. So, reject the null hypothesis and fail to reject the null. Fail to reject the null hypothesis. Okay, so this two, and to get the values of this, print f value value and print p value p value. Okay, so what output it will give? Okay, there is a colon. So chi-square value is 1.7 and p value is 0.79. So that means it failed to reject the null hypothesis. So what is the null hypothesis here? There is a significant difference between the observed and the expected distribution. Null hypothesis. Now that means what I said, and an average of 20 chips per cookies are present. This is the null hypothesis, and it failed to reject this. That means it accepts the null hypothesis. Failed to reject the null hypothesis. That means it accepts the null hypothesis. And if the p value is less than say 0.05, then it is reject the null hypothesis. That means there is, on an average, there is no 20 chips per cookies are present. It is okay for everybody, understandable? Now, so this is for the chi-square test for goodness of fit. Now there is a significance level, another value that is compare and comparison. So since the time is going short, let me wrap up it a little bit. So chi-square test is a statistical hypothesis testing test which is used to determine if a significant association between the categorical variable present or not. And there are two ways: the chi-square test for association and chi-square goodness of fit test. And that the process we have seen, that is the chi-square test for association fit, chi-square fit test for goodness of fit test. Sorry. And now we will see chi-square test for association. So same voting example we can consider. Okay, and we have the contingency table already generated. So from that contingency table, we can also generate the chi-square value. Say the goodness of fit test, chi-square goodness of fit test. And here it is chi-square test for association. So whether it is fit or not, whether the null hypothesis fit for that or not, that we can find out by using this. And now we will see the chi-square test for finding out the association between the gender and the preference, voting preference. Okay, for both the examples. Both the example means, so we have the contingency table. Here contingency table one, contingency table and contingency table one. Okay, so for this we will use one function from that same stats. So we will import it. Import typy.stats. Okay, it's not import, it's from. Import what chi2 underscore contingency. So we will use this library function. We will use this function and we will pass for the small data set. So print for the small voting data, and we will do the same thing for large voting data, where you have 200 rows. So the same code you have to write, that is chi2 underscore contingency, and then the contingency table. Contingency table. And here you have to use contingency table 1. Okay. So the contingency table has value 2 by 3, because 2 for male gender and 3 for voting preference. And here in contingency table 1, what is this? You have 3 by 4, 3 for gender and 4 for voting preference. Okay. So what output it will generate? First it will generate chi2 value, then the p value. Okay. And let's check with this. Chi2 small, p small. Chi2 large, p large. And then display them. Print chi2 small, and then print p small. Okay. This is for large. Too many values to unpack. So maybe I have changed the contingency value somewhere. What happened here? Contingency table. That's the cost tab. Yes, period of cost tab. Let's the moment try the next one, whether it has the same problem or not. CHI contingency. Should not give the error. Because it generates other values, so that's why. So these are forget about these two values for the moment. Our concentration is on this first two values. Expected small okay comma yeah. So for the small voting data set, you have chi small value is 2.22 and p small value is 0.32. And for the large voting data set, the chi-square value is 9.45 and p value is 0.14. So from here, there are other values are expected frequencies or all. I'm not going into all those values. So what it says, used to to conduct this test, create a contingency table. I have created it. Calculate the expected frequency for each cell under the assumption of the of independence. Then compare the expected frequency to the observed frequency using the chi-square statistics. If the observed and expected frequency, observed and expected frequency are significantly different, you can conclude that there is an association between the variable. So, and after that, So expected frequency, I have to use it. So see, in this case, the expected frequency here in the expected small and expected frequency in the large data set. Here you have the other values of these frequencies. So which is the calculate the expected frequency, how it calculates for each cell under the assumption of independence. Then compare the expected frequency to the observed frequency using chi-square statistics, and that the chi-square statistics gives you this value. After having those comparison, you get this value. This is the small one and this is the larger one. So if the observed and expected frequency is significantly different, that means if the chi-square value is large, you can conclude that there is an association between the variable. And if the difference is low, you can assume that the association is, sorry, what I said, if the difference is high, observed and expected frequency are significantly different, that means the chi value is high, then there is an association. If the chi value is low, then there is no association. So in this case, there is no association and there is more association between the two values. Okay. Why? Because both use random function, so or the same random function to generate it. So there is an association between these two values or to these two attributes. So this is what I can conclude from this chi-square test for association. Now, what are the assumptions you have to do in case of chi-square test? That independence of observation, the frequency of one category in one cell of the table should not depend on the frequency of another category in another cell. Okay, that means the values in the contingency table should be independent. It should not depend, but depend on another value. Random sampling, we should use random sample instead of any particular choice. You have to do random sampling when you are choosing the cookies in the cookie example. So the sampling must be random when you are taking the sample. Expected frequency, a common guideline is that no more than 20% of the expected frequency should be less than 5. If this assumption is valid, you may need to consider alternative methods for or use a corrected version of the chi-square test for this kind of for finding out the association between two values. And other limitations of this chi-square test, this works only on categorical data. For the numerical data, you have ANOVA or other test. And also it works on two variable. As I said that basically we will use two variables to generate the chi-square test, but more than two values can be used to generate a contingency table. Okay, that we will see with the e-commerce example. And no information about strength or direction. The association is exist. Like for example, remember the association between the liquid product and the solid product. If I say that okay, there is an association, but I don't know whether this is associated with this or the vice versa. That means the liquid product have a association on the solid product, or solid product has an association on the liquid product. These kind of things has major application in when you will explore association rules. You will know about this direction of association. whether A is associated with B and B is associated with A, whether they are same or they are different. Okay, basically they are different. That milk associated with sugar and sugar associated with milk does not have the same meaning always. It has the same meaning sometimes, but not every time. Okay, so like for example, if I say that whenever a person buy a milk, the person will buy sugar also. And if I say that whenever a person buy milk, buy sugar, that person will buy milk also. So although they look same, but statistically they are not same. So sensitivity to the sample size, if the sample size is too small or too large, then there is a problem in this case of chi-square test. Assume no missing data. When there is a missing data in the data set, the chi-square test will give you wrong result. Okay. Now the significance level. So let's go with an example. I'm skipping this part, going into the main content of the example. Yeah, this one. Interpretation and reporting. Say, for example, now you know many things about categorical data, how to convert it, how to generate different statistics, how to use the contingency table and others. And you have already seen how to use chi-square test. Now we will use a data set to work on this and try to understand the data set in an analytical manner. Okay, so although it is very small and not so healthy e-commerce data, it's a general e-commerce data, but you can get some idea. Okay, so in this data set, what we have 5 columns. What are those columns? Person. Okay, we have education level. We have income level. We have employment status. And we have the industry. Okay, and we will generate randomly all these things. So let's go one by one. The code for generating it. So what we need? We need to import the random function. We need to import the NumPy library as NP. Okay, and then we will create the categories. Educat, where I will use the short form. Okay, so HS, bachelor, master, PhD. Another one is income cat. Income category are, say, low income category, medium income category, high income category, Okay, these three. And then employment category. Employment category, we will use employed, unemployed. Employed, unemployed. Okay. Then the industry. INCAT is a technological industry, healthcare industry, finance industry, education industry, manufacturing industry, agricultural industry. Okay. And there is, say, for example, any. Now, what we will do, we will use these categories for generating the data randomly. Okay, so here the size is, say I want to generate a data set of 500 rows, and for the person I will give an ID sequentially 1 to 500. Okay, so I will use the person list is equal to list, and then a range of 500, and then edu list will generate a random dot choices educat, and k is equal the size. Okay, so I will copy this. How many times? 4 times. 4 times. And first one is edu, next one is income, third one is employment, fourth one is industry. Similarly, int list, emp list, income list, navigation list. So we will generate all those lists of values, and then by combining them together, all these 5 lists, I will create the data. So data is equals to the column name person. The value comes from person list. Mm-hmm. 2 times, 3 times, 4 times, 5 times. So here it is education, then income, then employment, then industry. So for this IND, for this EMP, for this INC, and for this edu. And now make them comma separated. Okay, and then you make the data frame. Ecom data is equal to pd dot data frame. Okay, just a minute. The data is created. If you want to know the value, print ecom data, and see here you have different values, 500 rows of 5 columns. Okay, now we will go for asking the questions from the data set. Okay, the first question what we will ask: what is the income distribution within different industry? So based on the industry, what is the income distribution of the income value? Okay, or the level of income. So if we get it, we can get it by using by grouping. So what we have to do, we have to group the industry based on the income. Remember, we in the last class we have used df dot group by. What you have to use, that is the industry, right? Based on this industry, because what is your question? Income distribution within different industry. Different industry, you have to group them based on the industry value. And then you have to get the income of that particular industry. So you get the income of that particular industry. And then describe method. What happened? Industry. What is the name? Industry. What happened? Key error. That is df dot group by. I will group by by industry, and then okay. Here we have ecom data, not the df. So ecom data. So we have this industries. How many industries? Agricultural, education, finance, health, manufacturing, not available, technological. And how many values you have in each in the data set? You can see 73 rows having agriculture as an industry, 72 rows having education as an industry, 54 rows having finance as an industry, like this. And here, in case of agriculture, 20 out of 73, 27 having high income. Out of 73, 27 having high income. And out of 84, having 35 as high income, medium income. And others are like 31 having high income in technology field. So if you look at this in the not available, this is basically having low values mainly 25. 25 rows having low income values. Okay, so you can now you can answer the question asked here. What is the income distribution? What is the income distribution based on the within the different industry? In this particular industry, income distribution is 27 having the top high income group. So summary statistics or visualization can help you to do that. Are there significant differences in income level between industries? If you look at this, so in this case, if you look at this, that from the finance sector and in the those who are having not available data, having mainly the low income, belongs to the low income group, majorly belongs to low income group. Okay, so like this, if you analyze this income value, income level, and the number of count and the industry and the frequency value here, you can get many different answers from for this question. Are there significant differences in the income level between the industries? Yes, for some cases. No, for some cases. And if you explore it, you can get more answer. Okay. Now coming to the next one, that is employment by income level. So what percentage of individuals in different income group are employed? So like high, medium and low income group, what percentage of this income group having employment percentage? So the cross tabulation or the contingency table will be better here between the employment and the income level. So let's create this. Create this for the second answer. Okay, or if you okay, we'll come to the visualization later. So answer 2. Answer of question 2, how you can get it by using cross validation, cross tabulation, or we call contingency table. So how to get that? There is a cross tabulation. So cross tab, where this cross tab is available in Panda. Which attributes you need for this cross tab? Income and employment. Okay. So ecom data income, comma ecom data employment, and what it will generate? Ecom cont tab. Print this and you can get the, based on the income level, you can see the employment status, that those in the data set, major a majority of the person belongs to medium income group, then the high income group, and then the low income group. Medium income group and high income group are having in equal number, almost in equal number, but low income group has significantly lesser than the other two groups. Okay, number of people in the data set having low income as per the employment status or as per the employment category, whether they are employed or not, based on that. Now, the low income group having greater unemployed person, okay, compared to the medium and high income. They are unemployed, that's why they are belong to the low income group. And the number is 91. Okay. So is there a pattern between income and employment status? Of course, you can find the pattern between the low income group and an unemployed, majority of the unemployed values. Okay. And if you convert it into percentage, you can get more better understanding of the result. And for this, what you can do for converting it in percentage, where is the percentage? Yeah, this one. So, is it clear for everybody what I am showing you based on the analysis, or how you can do analysis based on these categorical attributes and the measure? Yeah. So, from this percentage data, you can see majority of the unemployed youth are from the low income group, and majority of the employed youth are from high income or low medium income. Okay, and here in case of employed people or employed person, both are having equal number of percentage. Okay, so this is because this is the row wise distribution. So the total number of high income people, 50% of them are employed, and more than 50% are employed, and less than 50% are unemployed. So you can see the values are almost equal, near to 50%. Why? This is the nature, because the data is created randomly. If you have a real data, you can use the same procedure and you can try to find out the answer, and you can get many different values, many distributed values, and that can give you many better understanding of the data set between the two attributes, the income and the employment status. Okay. So, education and industry preference. Do people with specific education level tend to work in particular industry more often or not? Okay. So, for example, you want to get a question like this. So, what you have to do? So, again, contingency table, but in this time it is between education and industry. So this is education. This is industry. Okay. So you get the new table, new table, new table, new table, new relative frequency. So that kind of, for this kind of answer, let's see whether a relation exists in this or not. So see, those who are having PhD degree either mainly belongs to the technological industry. Okay, majority of them are belongs to the technological industry, and those are having master degree. Majority of them are in the education industry or manufacturing industry. Those who are having higher education, like higher secondary, like a school level degree, are having health sector and manufacturing sector or technological sector. Okay, and having bachelor degree mainly from this manufacturing industry. And in the agricultural industry, majority of the person having PhD degree or bachelor degree. Those who are having masters and school level degree are involved somewhere else. This kind of result or answer you can get from this analysis. Are certain industries more attractive to individuals with specific educational background? As I said, for the PhD people or for the master's degree people, the education and the manufacturing industry are more attractive. For the PhD degree, technological sector are more attractive. For the bachelor degree, manufacturing sector is more attractive. Like this answer you can get from this kind of analysis. Now, the fourth and last question is education distribution by industry. So, what is the distribution of education level within the different industry? What is the education level? So, okay, this for this question number 3. Uh, what you can do, you can use. I have used the row measure, right? Row wise relative frequency. You can generate column wise relative frequency, and you can get another set of results. Okay, so that are part of the experiment. You can do this kind of experiment, how you can generate column wise relative frequency that I have shown you. You can generate it and you can get the different result. Not different result, but different analysis. So education distribution by industry. So now distribution of education as per the industry. Let's see what is the distribution of education level within the different industry. So for this, what you have to do? Again, you have to count. So what distribution of education level within different industry? So let's do the group by count percentage breakdown for group by. So education distribution ecom data dot group by industry and education. Pulling it Okay. So this is the total number of person based on this education and industry. Okay, the distribution of number of people. Now, do certain industry tend to hire more highly educated individual? So for PhD degree, you can see that the same result which you have seen here. The 26%, 26 out of that, how many? I think how many rows I have created? 500. Out of 500, so 26. That means majority of these high educated people tend to go to technological industry. Okay, like this kind of things you can get from this kind of experiment. And with this, I finish my talk. If you have any doubt or query, please let me know.
So is it possible to save this worksheet that you have done in Colab, Google Colab?